the head of a linked list and a value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. So what we are going to do, if this is the linked list that is given to us, we are going to put all the values smaller than x. For this example, x is equal to 3. All the values smaller than x before the values greater than or equal to x. For solving this problem, as we don't have any space constraint, what we are going to do, we are going to say, and the number of nodes in it can be from 0 to 200. So we are going to first deal with the special case. We are going to say if not head, we are going to return none. And then what we are going to do, we are going to make two small linked lists. One linked list for the values that are less than x, and one linked list for the values that are greater than or equal to x. So we are going to make a dummy variable to build our linked list, a smaller linked list. So a smaller one is for the values that are smaller. So we need to keep the head because at the end we are going to return this one. So list node, we will leave it empty because the value that we have here by default is 0. So it's gonna make it node with value 0 in it, and then we're going to have larger. We don't need the head here, and what we are going to do, we're going to say list node and here. So then what we're going to do right now, what we have 0 1 0 here for the smaller and 1 0 here for the larger. Then we are going to iterate over the list starting from the head. So we're going to say while head, if the node is not empty, if it's not empty, what we're going to do, we check the value that it has in it. If the value is smaller than x, we need to add it to the smaller linked list, and if it is bigger than x, we need to add it to the larger linked list. So we are going to say smaller dot next is equal to head, and then we are going to move the smaller one step forward, smaller dot next, and now we need to deal with the values that are bigger than or equal to x. We are going to say larger dot next is equal to head, and larger is equal to larger dot next, which we are going to move forward. So let's see what this does. So starting from here, 1 is smaller than x. So if it is smaller than x, it's going to be added to the smaller linked list. So 1 is going to be here. Then we have 4. 4 is bigger, so it's going to be the bigger linked list. And then we have 3. 3 is equal or larger, so we're going to have 3 here. And we have 2, so 2 is smaller, we are going to have it here. And then we have 5. 5 is bigger, so we are going to have it here. And then we have another 2, and we're going to have it here. So now we have built our smaller and larger linked list. Now we need to combine them, but before combining them, we need to deal with two situations. First thing is, because this is going to be added at the end of this one, we need to make sure this one is pointing to not, because this is going to be added at the end. So we are going to say larger dot next is going to be none, and then now we have none here. Then what we need to do, we need to get rid of this. For doing that, we are going to say smaller dot next, we are going to add it to larger. We need to have the head here too, larger head. We are going to say larger head dot next, because we don't need to have 0 here. So it's gonna be something like this. And at the end, what we're going to do, we are going to return smaller dot next as the result, smaller head dot next. And I forgot to move the head one step forward here, so it should be all good. And let me remove this, and let's run the code and see if it works. Yeah, there you go, it works. So The space complexity for this is going to be linear, and the time complexity is going to be linear as well, because we are making two smaller linked lists here equal to the size of the original list, and we need to iterate over the actual linked list, original linked list once. Thank you.